Welcome back to The Explainer. So today, we are looking at an absolutely staggering contrast. We're talking about the biological perfection of killer whales out in the wild compared to their documented reality when they're kept in captivity. By diving into the latest marine biology research, we're going to find out exactly what happens to these highly intelligent apex predators when their entire world is just radically altered.
Right off the bat, we have to ask, what happens when an apex predator, an animal literally designed to swim 100 miles a day, is confined to a concrete tank? It's a profound question, right? To really grasp the impact of that, we first need to establish a baseline of how these magnificent animals are biologically engineered to thrive in the open ocean.
Okay, let's dive into this. Part 1. The majestic wild baseline.
Now, in their natural habitat, these are massive, incredibly complex creatures. And one of the most defining features of their society? Longevity. Just look at this number. 100. In healthy wild populations, female matriarchs like the famous Granny or J2 have actually been recorded living over a century. It's amazing. And under what's called the grandmother hypothesis, these elders act as absolutely vital repositories of ecological knowledge. They're the ones guiding their pods to food and passing down crucial cultural survival skills.
But when we compare that wild baseline to captive orcas, the contrast is honestly pretty stark. Wild females average 50 to 100 plus years, yet the median captive lifespan, it's under 30 years. Now, while some industry models might claim these lifespans are roughly equal, marine biologists point out some severe methodological flaws in those studies. For instance, extrapolating a calf's survival rate just a few years out to predict the 50-year life, which kind of ignores the grim reality that most captive-born orcas pass away in their teens or 20s.
That brings us to Part 2, the physical toll of confinement. You see, when you take biology designed for the deep ocean and constrain it, you get some staggering statistics, like 100%. Approximately 100% of captive mature males experience complete dorsal fin collapse. Out in the wild, this happens to less than 1% of males and usually from a specific injury. But in captivity, these whales spend about 90% of their time just floating at the surface. So without that deep water pressure, or the muscle tension from rapid swimming, gravity literally just causes the fin's connective tissue to buckle.
Another really major physical indicator is severe dental damage, which leads to a procedure called a pulpotomy. Basically, chronic boredom and extreme confinement causes what researchers call oral stereotypies. This means the whales obsessively chew on the concrete pool walls and steel gates, eventually shattering their teeth. To prevent fatal jawbone infections from that, trainers literally have to drill holes directly into the living pulp cavity of the tooth to drain the infection. This is done without anesthesia, and the bore holes are left uncapped, which requires daily flushing and inevitably leads to chronic, multi-drug-resistant bacterial infections.
And this brilliantly illustrates how, beyond just the tank walls, the artificial environment itself introduces entirely new pathologies. Captive orcas are exposed to chlorinated water that's often stronger than household bleach, which obviously irritates their skin and eyes. And because they float at the surface so much, they're bombarded by intense UV radiation, leading to sunburns. Even more concerning, this stagnant surface floating exposes them to mosquito swarms that transmits fatal land-based diseases like West Nile virus, threats that are entirely 100% absent in the cold, moving currents of the open ocean.
Let's move on to Part 3, psychological trauma and aggression.
Moving beyond the physical degradation, researchers have documented a really profound psychological collapse. A key state they observe is known as learned helplessness. It's essentially a behavioral analog to clinical depression. In the wild, if a conflict arises, an orca can simply swim away. But in a tank, subordinate whales get cornered, leading to severe conspecific aggression and deep rake marks. Once they realize they have zero control over their environment, they kind of sink into this depressed state of prolonged sedentary floating. And to chemically manage this extreme stress, facilities have relied heavily on psychotropic drugs like Valium just to keep the whales calm. We also have to look at the profound trauma of mother-calf separations. Out in the ocean, resident orcas stay with their mothers for life. It's a fundamental part of who they are. But in captivity, these vital, lifelong matrilineal bonds are frequently broken for commercial transport. For example, when Katina and her 4-year-old calf, Kalina, were separated, researchers noted that Katina spent the entire night alone in the corner of her tank, physically shivering and emitting these heart-wrenching distress vocalizations. This doesn't just cause psychological trauma, it completely destabilizes and destroys the cultural transmission of their survival skills.
This brings us to a really fascinating, though tragic, historical transition regarding aggression toward humans. Back during the petting pool era of the late 70s to early 80s, young wild-caught orcas actually engaged in unstructured play with humans, and there were zero violent incidents. But when they were forced into strict performance regimes, human-targeted aggression suddenly spiked. Scientists propose something called the failed strategic alliance hypothesis. It suggests these highly intelligent whales initially tried to build empathetic alliances with humans, but when that failed to win them any autonomy, their extreme frustration triggered retaliatory violence.
We also need to objectively look at the genetic outcomes of captive breeding programs. Because the global captive population was so incredibly small, it created a severe genetic bottleneck. This led to incestuous pairings, most notably the mating of an 11-year-old male named Taku with his own mother, Katina. You see, in the wild, these animals have highly sophisticated acoustic mechanisms to completely avoid inbreeding, but in small, artificial pools, those natural boundaries were entirely dismantled.
Let's move to and see how this builds into Part 4, the crisis in the wild. Now, it's important we look at the other side of the coin, because while captive orcas suffer in tanks, free-ranging pods are fighting their own desperate battle for survival. 74. Just 74. That is the number of southern resident killer whales remaining as of the July 2025 census. This unique fish-eating ecotype that ranges from California to Alaska is now critically endangered. So their pristine wild baseline that we talked about earlier, it's actively being dismantled by human-caused threats.
The primary mechanism driving this extinction is what researchers call the toxic starvation cycle. Here's how it works. Step 1. Their preferred prey, Chinook salmon, fails due to habitat destruction. Step 2. Facing starvation, the orcas are forced to metabolize their own blubber for energy. And Step 3. This metabolic process releases highly concentrated, toxic, bioaccumulated pollutants, like PCBs, directly into their bloodstream. This causes acute immunosuppression and devastating reproductive failure. And compounding this starvation is something called acoustic masking. Honestly, imagine trying to find your dinner blindfolded in a room with a blaring jet engine. Because orcas rely entirely on underwater echolocation to hunt salmon, the constant noise from commercial vessels and ferries essentially blinds them. Studies actually show masking occurs 85% of the time during feeding. This forces these already hungry whales to call louder and expend precious energy just to navigate the Salish Sea.
Which brings us to Part 5, Pathways to Orca Recovery.
Now, what's really interesting about this slide is that the research isn't just a depressing list of problems. It actually offers converging solutions. Demographic modeling for the southern residents reveals something incredible. Yes, on our current high development trajectory, the population declines by 1.7% annually. But the data clearly shows that if we increase Chinook salmon abundance by just 15% and reduce vessel noise by 50%, we can literally reverse their extinction, achieving a 2.3% growth rate. So, it is entirely within our power to fix this.
Simultaneously, we're seeing a massive global shift in policy regarding captive welfare. We've got key legislative milestones, like the 2016 California Orca Protection Act and Canada's historic 2019 Bill S-23, which is the Ending Cetaceans in Captivity Act. These have formally banned the breeding, trade, and theatrical performances of cetaceans. Basically, lawmakers are establishing the legal and moral precedent that these complex, socially sensitive beings simply cannot be kept in concrete tanks anymore.
So, what about the whales already in captivity who lack the skills to survive the open ocean? Well, the solution lies in seaside sanctuaries. Unlike commercial parks with small, chlorinated tanks, proposed sanctuaries, like Port Hilford Bay in Nova Scotia, offer vast 100-plus-acre coastal bays with natural ocean currents. Now, it comes with immense engineering challenges, for sure, like maintaining taut nets and ensuring environmental safety, but it offers a humane, non-commercial retirement that actually promotes natural behaviors.
So, the crucial point is this. We have the scientific data, we understand their biological perfection, and we know exactly what is destroying them, both in concrete tanks and out in the wild. The solutions are literally right in front of us. So, will we restore their ocean habitats and grant them sanctuary, or simply watch them fade away? Thank you so much for joining me for this explainer. I really hope this leaves you inspired to dig deeper into marine conservation.